Number 13, a block accelerates 3.1 meter per second squared down a plane. So it accelerates down the plane, inclined at an angle 30 degree. So this is theta, 30 degree. Acceleration of gravity is 9.81. This is the G. Okay. What is the coefficient of friction? Mu. Okay. Coefficient of friction between the block and the inclined plane. Okay. So first we have to draw all the forces acting on this block. So the block has weight vertically downward, and then it is on the plane, on surface, so it has normal force 90 degree to the plane. Alright, and then it move down the plane, and the plane has friction. That means the friction is up the plane, because direction of friction is always opposite direction of motion. Okay, then we can resolve weight into component which is perpendicular to the inclined plane, which is Wy, and component which is parallel to the inclined plane, which is Wx, where Wx is W sin theta and Wy is W cos theta, and W is mass times gravity. Okay, so look at this area. Okay, so for this component, okay, we must apply net force X equals to ma, because it is accelerate at X component. Okay, so Wx in the same direction of acceleration. Look at the arrow. Wx arrow is in the same direction of arrow of acceleration, so they are in the same direction. So Wx is positive and friction is opposite direction of acceleration, so friction is negative. So this one will be Wx minus friction, or Wx plus negative friction. Negative friction because friction is opposite direction of motion, equals to ma. So Wx is W sin theta. So W is mg. So it become mg sin theta, and friction is equals to coefficient times normal. Okay, times normal force, equals to ma. Alright, so we have two unknowns, mu and normal. Okay, so we leave this equation first and consider for y component. Net force y equals to 0. For y component, this block is in equilibrium. It doesn't move at y component, so it is in equilibrium. Only it is accelerate only at X component. So net force X equals to ma, and net force Y equals to 0. So for Y component, we have N and Wy. Okay, N and Wy. So N is upward and Wy is downward. So Wy is negative. Okay, maybe we can let N be the subject. So N equals to Wy, where Wy is W cos theta and W is equals to mg. So N equals to mg cos theta. Okay, so this is the equation 1 and this one is equation 2. Maybe we can substitute equation 2 into equation 1. Okay, and maybe we can substitute mass, but mass is not given, right? Okay, mass is not given. Never mind, we can proceed m in terms of m. Okay, mass in terms of m, and then g. Okay, g is 9.81. Sine 30 degree minus mu, and then n is g is 9.81 cos 30 degree. Okay, equals to ma. So mass in terms of m, and then a here is 3.1. Okay, so we can factorize. Okay, we can factorize with m. So 9.81 sine 30 degree, 9.81 sine 30 degree equals to 4.905, and then mu is the unknown. We already factorize m, and then calculate the value of 9.81 times cos 30 degree. So it is equals to 8.496. Okay, so 8.496 mu. Okay, equals to 3.1 m. So we can cancel m. Okay, we can cancel m. Okay, so at the end we can determine the coefficient of friction mu. Okay, so it is equals to 4.905 minus 3.1. Okay, divide with 8.496. So it is equals to 0.212. Okay, so there is no unit for mu. Okay, coefficient of friction has no unit, because coefficient of friction mu is the ratio of frictional force to the normal force. It is from here friction equals to mu times normal. So mu actually is the ratio of friction to normal force. Okay, so both friction in unit Newton and normal force in unit Newton. So we cancel the unit. So mu has no unit. Okay. Number 14, a 2.5 times 10 to the power of 3 kg crate M1 rests on an inclined plane and is connected by a cable. Okay, this is the cable to a 4 times 10 to the power of 3 kg mass M2. Okay, this second mass M2 is suspended over a pulley. Okay, so this is the pulley. This one is M1 and this one is M2. M2 is suspended. M1 is rest on the inclined plane. The inclined angle is 30 degree. So this is the angle theta, 30 degree. And the surface is frictionless. That means there is no friction. Determine the acceleration A of the system and the tension in the cable T. Okay, so first we have to draw all the forces acting on these two objects. So we have two objects, okay, M1 and M2. So we will have two free body diagram. Okay, so for M1, M1, okay, it has weight W1, and then it is connected to a cable, so it has tension away from M1, and then it is on inclined plane, so it has normal force 90 degree to the inclined plane. And then we can resolve weight 1 into component which is parallel to the inclined plane. Okay, it is W1x, and component which is perpendicular to the inclined plane, which is W1y. Okay, where W1x is W1 sine theta, and W1y is W1 cos theta, and W1 is M1 times gravity. Okay, so this one is for M1. How about M2? So for M2, it has weight 2, okay, weight of mass 2, and then it also connected to the cable, so it has tension, okay, T, away from weight 2. Okay, tension on M2 is equals to tension on M1 because it is the same cable, so it has same tension. Okay, but tension on M1 is away from M1, and tension on M2 is away from M2. Okay, so for this system, is M1 move up the plane or down the plane? Okay, so we have to check on the mass. Okay, mass of M1 is 2.5 times 10 to the power of 3, and mass of M2 is 4 times 10 to the power of 3. So mass M2 is greater than mass M1. Okay, so M1, okay, M1 will move downward, will accelerate downward because the mass is greater, and it will pull M1 up the plane. Okay, like this. Okay, so M1 will slide up the plane, and M2 will move downward. Okay, so M1 and M2 should move synchronized, okay, because they are in the same system. Okay, alright, so let us solve this one. Okay, so we have to solve by object. So for M1, okay, so it is accelerate at x component. This one is the x component. Okay, this one is the x component for M1. So we have tension and W1x, and the tension is in the same direction of A. Okay, tension in the same direction of A. Look at the arrow. So tension is positive, and so we should apply this one. Net force X equals to MA, because for M1 accelerate at X component. Okay, along the inclined plane. Okay, along the inclined plane. So tension is in the same direction of acceleration, so tension is positive, and W1x in opposite direction of A, so W1x is negative. So it will be tension plus negative W1x, okay, equals to M1A. W1x is W1 sine theta, and W1 is M1 times G. So it becomes T1 minus M1 G sine theta equals to M1A. Okay, so maybe we can substitute m1. m1 is 2.5 times 10 to the power of 3. G is 9.81. Sine theta is 30 degree. Okay, m1 is 2.5 times 10 to the power of 3 times A. Okay, so maybe we can calculate value of 2.5 times 10 to the power of 3 times 9.81 times sine 30. So it is equals 122.62.5. Okay, equals 2500A. So we have equation with two unknown, T and A. Okay, so this is the first equation. And then for M1, okay, for M1 it is accelerate at component X and it doesn't move at component Y. So for component Y, for M1, it is in equilibrium. Net force Y equals to 0 for M1. So for component Y, okay, component which is perpendicular to the inclined plane is normal. So we have normal and W1Y. Okay, so it will be N plus negative W1Y equals to 0. So let N be the subject. N equals to M1G cos theta. Okay, but we don't use this component. Okay, we don't use this component Y. Okay, because the surface is frictionless. Basically, we will use component Y to determine N. Okay, because we want to find the value of friction by using formula friction equals to mu times normal. So normal is from the component Y. For this one, we don't use this component because there is no friction. Okay, frictionless. Okay, and then we can proceed to M2. Okay, we can proceed to M2. Okay, M2. Okay, so this is M2. Okay, it has weight 2 and tension upward, and M2 move downward. Okay, M2 move downward, accelerate downward. Okay, so it is accelerate at Y component. So net force Y for M2 is equals to MA. It is accelerate at component Y. So W2 is in the same direction of acceleration. So W2 is positive, and tension in the opposite direction of acceleration. So tension is negative. Okay, W2 plus negative T equals to M2A. So W2 is mass 2 times gravity. Okay, and then we can substitute mass 2. Mass 2 is 4 times 10 to the power of 3, and G is 9.81. Okay, minus T equals 2, 4 times 10 to the power of 3A. Okay, maybe we can calculate value of 4 times 10 to the power of 3 times 9.81. So it is equals to 39240. Okay, minus tension equals to 4000 A. Okay, so we have second equation with two unknown. Okay, T and A. So the rest is mathematics. Okay, so maybe from equation 1. Okay, from equation 1, okay, we can let T be the subject. Okay, so T equals to 2500A plus 12262.5. Okay, equation 1. So maybe we can substitute equation 1 into equation 2. Okay, maybe we can substitute equation 1 into equation 2. Okay, equation 1 into equation 2. Okay, so 39240 minus t, where t is 2500a plus 12262.5, okay, equals to 4000a. Okay, so for this equation you only have one unknown, okay, a, so we can determine a. Okay, 12262.5 equals to 26977.5. okay, equals 4000 plus 2500. Okay, so it is 6500a. So a equals 6977.5 divided by answer. So 4.15. So acceleration equals to 4.15 meter per second squared. So we have already calculated acceleration A. And then how about tension? Okay, so maybe from equation 1. Okay, from equation 1. Okay, so T equals 2500A, where A is 4.15 plus 12262.5. So tension equals 638.46 Newton. Okay, so this value is equivalent to this one. Okay, alright.